This lecture we will see one important theorem related to invertibility of a matrix and elementary matrices. This is the last theorem of the elementary matrix part. So let us see the theorem. Theorem statement is, let A be an n by n real matrix, then A is invertible if and only if A is a product of elementary matrices. A is a product of elementary matrices. That is, inverse of A exists if and only if A can be written as a product of elementary matrices. In the first part, we will see the proof that A can be written as a product of elementary matrices if A is invertible. That is the direct part. For that, we have to suppose A is invertible. Suppose A is invertible means what? Inverse of A exists. Means by the previous theorem, this matrix A is invertible, then we see that A is invertible if and only if A is row equivalent to identity matrix of order n. So A can be reduced to a identity matrix of order n. That is, A is row equivalent to identity matrix n. That is, A is row equivalent to identity matrix Rn, or you may write simply I. A is row equivalent to identity matrix means there exist elementary matrices E1, E2, Ek such that A in product of Ek, Ek minus 1 and so on E2, E1 into A is equal to identity matrix. So this matrix A can be written as, then each elementary matrices are invertible, so we can write this matrix A as A is equal to, by this expression, taking this whole quantity product to the left side, that is multiplying Ek inverse, Ek minus 1 inverse and so on, we get A is equal to E1 inverse, E2 inverse and so on, Ek minus 1 inverse and Ek, this is Ek. So we get A is equal to E1 inverse, E2 inverse and so on, Ek minus 1 inverse, Ek inverse into I. I is an identity matrix. So this can be written as E1 inverse, E2 inverse, E3 inverse and so on, Ek minus 1 inverse Ek, since elementary matrices are invertible. And since each elementary matrix is invertible and inverse of elementary matrix is again elementary, so E1 inverse, E2 inverse, these matrices, E1 inverse, Ek inverse, Ek minus 1 inverse, E2 inverse and E1 inverse are all again elementary matrices. Inverse is again elementary. So we have from this expression we can see that this matrix A is a product of E1 inverse, E2 inverse, E3 inverse and so on, Ek minus 1 inverse and Ek. So A is a product of elementary matrices because this E1 inverse, E2 inverse, E3 inverse and so on, Ek minus 1 inverse and Ek inverse are all matrices. All these matrices are again elementary matrices because inverse is again elementary matrices. So A is a product of elementary matrices. This proves the proof of the direct part. So conversely we have to suppose that A is a product of elementary matrices. So conversely suppose that A is a product of elementary matrices. So what we have then, A is a product of elementary matrices, that is A is equal to E1 E2. For our convenience, suppose A1 E2 Ek here, E1 E2 Ek, E1 E2 Ek. So then each these are elementary matrices. Each elementary matrix is invertible, that is E1, E2 and so on, Ek is invertible. So this product is invertible because product of invertible matrices is again invertible. Thus A is an invertible matrix. This ends the proof of the theorem, hence the proof. Thank you, students.